sphere of radius 30 centimeters is sitting on the base of a container of water. The water level is rising at a rate of 2 centimeters per second, so that the sphere is gradually becoming submerged. Let h be the height of the water. The submerged portion of the sphere is as shown below. The volume of the submerged portion is given by V is equal to pi h squared over 3 times 3r minus h, where r is the radius of the sphere. Use this formula to calculate the volume of the entire sphere to the nearest cubic centimetre. So when it's just submerged, we can see that h would be 60, which is 2 radii. Remember, r is 30. So v is going to be pi times 60 squared divided by 3 multiplied by 3 times the radius, so that's 90. Take away h, which is 60. So we just need to calculate that. Just clear anything that's there. So that's going to be pi times 60 squared divided by 3, and of course we're multiplying that by 30. So that's it in terms of pi. So we'll put down 36,000 pi. And then let's give it to the nearest whole number. So that's going to be 113,097 cubic centimeters. Find the values of h for which dV/dh is 0. So v, if we expand this out, so pi h squared over 3 times 3r would be pi h squared r, and then we'll have pi h cubed over 3. But don't forget here that r is this fixed value of 30. So that's going to be 30 pi h squared, take away pi h cubed over 3. So dV/dh is going to be 60 pi h, take away pi h squared. So if we want that to be 0, 60 pi h minus pi h squared equals 0. So pi h squared is going to be 60 pi h. Or we could have h is equal to 0, or we can divide through by h, in which case we can divide through by pi anyway, so let's do that. We get h is equal to 60. So h is 0 or h is 60. Calculate the rate at which the submerged volume of the sphere is changing at the time when the sphere is half submerged. Now we have dV/dh from part B. This information here is dH dt, which is equal to 2. And we're after dV dt. So dV dt is going to be dV dH dH dt. And that's going to happen when it's half submerged, in other words, when h is equal to the radius of 30. So what we're going to get is dH dt is of course 2. Then we've got 60 times pi times 30. Take away pi times 30 squared. So we just need to calculate that. So that's going to be 2 open bracket 60 times 30 times pi, take away pi times 30 squared. And you put 3 squared there, just be careful. And that gives me 1,800 pi. So let's get that as a decimal. So 5,655, and what was it, dVdt, so that's going to be centimeters cubed per second. Consider the following conjecture. Every 1% increase in h leads to approximately a 3% increase in v. Using the formula delta v is dVdh delta h, explain whether the conjecture is true or false. So delta v is going to be equal to dVdh, which is this. I'm just going to factorize this. So let's bring out a pi h, and then we'll have 60 minus h inside there, and delta h. And what I want to do is divide both sides by v. And of course v is pi h squared over 3. 3r minus hr is 30, so that's 90 minus h. So what can we do from there? Well, certainly the pi's cancel and one of the h's cancels, and we're dividing by this 3, so that can flip up to the top. So this delta v over v is going to be 3, 60 minus h, 90 minus h, and the h here I'm going to put over here as delta h over h. Now essentially this is the percentage change in v, or it would be if I multiplied it by 100, and this is the percentage change in h, or it would be if I multiplied it by 100. And what we're saying is a 1% change here would give us a 3% change there. But just suppose for an example, if h is equal to 60, then any change in delta h over h gives a 0% change in v. So what we have here is a counterexample, and of course there's other ones that we could use as well that would show that this wasn't true.